Okay, good afternoon class. So today we're looking at analytical geometry. We're on exercise 4 point. The homework was exercise 4.5. Okay. Exercise 4.5 we had to do. So we did 4.4 already. Sorry? Yeah, we spoke about number 2 already. Well, that's part of the homework. 1 and 4. Any issues with number 2? Anybody have a problem with number 2? No?
Life sciences.
In the maths meeting.
Sorry.
Okay, so number 2, in A, they ask you to work out P1. Once you got P1, they ask you then to work out angle Q1. And then they ask you to work out angle R. Here we're going to say exterior angles equal to the sum of the two interior arcs. Not so. So no problems in number 2. Number 3. Any issues here? Yes, okay. So this is exercise 4.4 on page 94. So we are told that A, which is 2 and... Okay, so here's a problem. A is supposed to have been negative 2 and negative 2. Where do I get that from? Okay. B, which is 1 and 2, and C, which is 2 and negative 1. Are 3 points in the Cartesian plane. Alpha and theta are the inclination angles of lines AB and CD respectively. Because we just say in that order. The first question says calculate theta. So there's theta. So to work out theta, I need the gradient of BC. So gradient is change in y over change in x, so it's negative 1 minus 2 over 2 minus 1. Which works out to be, negative 3. So arctan of negative 3. Arctan shift tan of negative 3. We do negative 71,56 and add 180 to it. Give me 108. Is that the answer they have there? 108, comma 4. Okay, let's look at B. B says alpha. So this is angle alpha. So tan of alpha equals the gradient of AB now. So it's going to be 2 minus minus 2. 2 minus minus 2. And 1 minus minus 2. So that's 4 over 3. So alpha is equal to arctan of 4 over 3. This arctan of 4 over 3 gives us an answer of 53,13. So it's 53,1. Then angle B. To work out angle B, we are the same. This is the other color we did before. We know the exterior angle, which is theta, is equal to alpha plus angle B. Exterior angle of triangle. Do I need to state the reason here? No, you don't need to state the reason. It's not Euclidean geometry. So theta is 108.4 equals alpha, which is 53.1, plus your beta angle. So beta works out to be 108.4 minus 51, 53,1. Gives you 55 comma 3. So where you go wrong, Anika?
So I think it's just all the diagram with the wrong numbers.
Okay. But didn't it occur to you that A, which is in the third quadrant, has a positive X and Y? You don't think like that? When I saw the numbers, the first thing I checked, hey, this doesn't look like, let's see what it's saying. Okay. This is number 3. Let's look at number 4. We did number 4. No? Yes? Number 5. Look at number 5 quickly. We are told that the equation of the line through L and P. The line through L and P is y is equal to x plus 3. That's y is equal to x plus 3. And MP is a straight line. Y is equal to negative x minus 1. LP and MP intersect the point at P. L1 and M1 are the inclination angles of line LP and MP respectively, which means to say that order. The first question says, calculate the following correct to one decimal place. Angle L1. So what do I need to calculate angle L1? I need the gradient. So tan of angle L1 is equal to the gradient of PL. Not so? So what's the gradient of PL? 1. Where do I get that from? From D. Okay, it's 1. So tan of angle L1 is equal to 1. Of tan of 1 is 45 degrees. That is 45. Okay. B M1. This is an angle B. So we say tan angle M1 is equal to the gradient of PM. So tan of angle M1 is equal to negative 2. Of tan of negative 2 is negative 63,43. You add 180 to it. It's 116,6. 116,6 degrees. The next one. They ask you to work out P1. How do you work out P1? You can say the exterior angle, which is 116,6, is equal to angle P1 plus 45 degrees. Why? Exterior angle is equal to the sum of the two interior opposite angles. Okay? So it's 116,6 minus 45 degrees. 71,6. So P1 is equal to 71,6 degrees. Then P2, so angle P2 plus 71,6 is equal to 180. Why? Straight line. So angle P2 is going to be 180 minus that angle of 71,6 gives us an angle of 108.4. So 108,4 degrees is your P2. Okay. Any confusion there? Right. 6. Any issues here? Any problems here? No? Equations of straight lines, we started the section as well. We did example 1. Then we were at example 2. No? So I had to leave. Is that correct? Alright, so let's look at example 2 quickly. So in example 2 is this on page 97. Example 2 on 97. It says, determine the equation of the straight line that passes through A, which is 1 and 2, and B, which is 3 and 8. So the equation of a straight line will be in the form of y equals mx plus c. To work out m, how do I calculate m? y2 minus y1 over x2 minus x1. So if that is x1, that will be y1. If this is x2, that will be y2, and vice versa. If I had made this x2, that would be y2, x1, y1. Okay. But the catch is, if I make this x1, that must be y1. Or if that was x2, that had to be y2. Okay, make sense? So what do we say? 2 minus 8 over 1 minus 3. Okay. 2 minus 8 is negative 6 over negative 2, which is 3. You all agree with that? So the equation now reads y is equal to 3x plus c. To calculate the value of c, I can substitute any of these 2 points in. So I'll substitute a, which is 1 and 2. I could have substituted b, it would have given me the same answer, provided that my gradient is good. Okay? That's x and a y again. There's your y, so 2 is equal to 3 times 1 plus c. So c is negative 1. Y is equal to 3x minus 1. Okay. In example 3, we spoke about that. Example 4, I didn't do, no? So let's do example 4 in this on page. Sorry? Page 98. So we are told determine the equation of a straight line L, which is parallel to the line 4y plus 3x equals 8. It passes through that point. So if lines are parallel, so the one line is y, 4y plus 3x equals 8, is parallel. If lines are parallel, what do we know? Gradients are equal. So gradient 1 is equal to the gradient 2. And that line that you must calculate is passing through the point negative 4 and negative 6. Okay? Basically what's happening. It's actually the lines are going the other way, so it's a decreasing graph. Okay? It's actually going the other way. But anyway, so firstly we must extract what the gradient of line 1 is. Not so. So how do I do that? How do I get the gradient given the formula? I must get it in standard form is y is equal to mx plus c. That is your standard form. Okay. So how do I get that? I make y the subject of the formula. I take, so you got 4y plus 3x equals 8. You take that over the equal sign, becomes 4y is equal to negative 3x plus 8. Divided by 4. So divided by 4, y is equal to negative 3 over 4x plus 2. So what do we say? The gradient 1 is equal to the gradient 2. Not so? So the first gradient is equal to the second gradient, which is equal to negative 3 over 4. Why? Because the lines are parallel. Okay. So what do we say now? Now we say y is equal to negative 3 over 4x plus c. Now we substitute a point that's lying on this graph that we're calculating. The equation we're calculating, which is negative 4 and negative 6. Remembering this is an x and a y. So negative 6 is equal to negative 3 times negative 4 times negative 4 plus c. Okay? So of course negative 4 is cancelled. So we'll have negative 3 over the equal sign become positive 3. So negative 6 plus 3 is c. So c works out to be negative 3. Therefore my equation is y is equal to negative 3 over 4x minus 3. That's the equation. Is that correct? Huh? That's correct. What do they have? Minus 9. Yes. This here. So I took that over. That's correct. So negative 3 over negative 4. Just hang on. Oh, yes, my mistake. Yes. So this is supposed to have been negative 3, which is negative 9. Huh? This is my mistake. Sorry about that. So why didn't you tell me earlier when I made the mistake? Huh? Or you just want to see where... Oh, you noticed that. Alright. Sorry about that. Then you went on to question exercise 4.5, correct? In 4.5 you had to do alternate sums. No? So let's start here. I'll take this off. It's on page 90, 99. Okay. Exercise 4.5 on page 99, we are told determine the equation of the following straight lines if the line has a gradient of 4 and passing through A, which is 2 and 3. Okay? So number 1A. So the equation of a straight line will be in the form of what? Y equals mx plus c. The gradient is 4, so y is equal to 4x plus c. Not so? So I substitute the pointless line on this graph, which is A, 2 and 3. Remembering that's a x and a y. Not so? So 3 is equal to 4 times 2 plus c. 4 times 2 is 8. Not so? Take it over, becomes negative 5. Is that correct? See if you notice the right answer or not? He's right. Just let me know when it's wrong. I make a mistake. So is it going to be C? C, we are given the gradient of a line is 6 and passes through. Again, it's in the form of y is equal to mx plus c. So your gradient is 6. So y is equal to 6x plus c. I'll substitute the pointless line on this graph, which is c, which is 5 and negative 3. Again, that's an x and a y. So negative 3 is equal to 6 times 5 plus c. That's going to give us 30, not so? We take it over the equal sign, so negative 3 minus 13 is negative 33. So y is equal to 6x minus. Okay, is that correct? Right, nice. Look at number 2. Do the 2a. Determine the straight line passing through those points. So it's going to be P. So it's y is equal to mx plus c. So we started by working out the gradient. So y2 minus y1, so it's 3 plus 2 over x2 minus x1 would be 0 plus 1. Give me a gradient of